we're going to talk about logarithms. So let's talk about logarithms and how we can apply these in MCAT physics. Well, if we have the expression logarithm base 10 of y equal to x, this means that we have the function that says that the base would be this one here. We call it the base, so the base is 10, and the base is elevated to the x, and that's going to give you the y. So we have these expressions which are equivalent. Let's do an example. You got the logarithm base 10 of 10, and that's equal to 1. And that's because if you take the base here, the base, and you elevate it to the first power, you get your 10. If you take logarithm base 10 of 100, that's going to be 2. And that's because if you take the 10, the base right here, and you elevate it to the second power, you get 100. And then the logarithm base 10 of 1,000 is going to be 3, because if you take your base, which is 10, right here, your base, and you elevate it to the third power, your 10 to the third power, you get your 1,000. And if you take the logarithm base 10 of 10,000, that's going to be 4. And that's because if you take the 10, which is your base right here, and you elevate it to the fourth power, you're going to get your 10,000. And that's how you play with logarithms. And we also have some rules. One rule says that the logarithm base 10, and you don't have to write the 10, but I'll do it for simplicity. When you see this expression, this one right here, the one that I'm pointing with the arrow, you don't have to put the 10, but I'll put it right here, and everybody understands that this is the logarithm base 10. So the rule is this one. The rule says that, I'll do the rule first and then an example, says that the logarithm of m times n is equal to the logarithm of m plus the logarithm of n. And let me put it in the other notations to keep the notation the same notation. Right there you go. So let's do an example. So we got the logarithm base 10 of 10 times 10, and that has to be equal to the logarithm base 10 of 10 plus the logarithm base 10 of 10. And we have that because this is going to be 100, and the logarithm of 100 over here would be this one right here. This one is going to be 2. We already have it over here. Over here, we have it over here. Right here, we have it right here. This one here. So let me erase this part here. We have it right here. Let me put it in another one. It's right here is this one, this one. So that's going to be 2. And over here, logarithm base 10 of 10 is 1 plus logarithm base 10 of 10 is 1, and that's equal to 2. So we see they match. The other rule says that the logarithm base 10 of m divided by n is equal to the logarithm base 10 of m minus the logarithm base 10 of n. Again, we got the logarithm base 10 of let's say 1,000. M is going to be 1,000 and n is going to be 10, and that has to be equal to the logarithm base 10 of 1,000 minus the logarithm base 10 of 10. Well, this one, we can cancel 1 0 or 1 0. So we got the logarithm base. I'll do it here. Logarithm base 10 of 100. This one is going to be 3 because we already have it. We have it over here, right here. It's going to be a 3 minus logarithm base 10 of 10. We know it's 1. So the logarithm base 10 of 100, we know it's 2. We did it already in the previous table. So it's going to be 2 equal to 2. And there you go. And then we have a third one, which says that the logarithm base 10 of m to the n is equal to the logarithm base 10 of n times m. Again, let's do an example. So we have the logarithm base 10 of 1000. Let's say it's let's say it's 100. 100 elevated to the square. In this case, our m is going to be 100 and our n is going to be 2. So this is going to be a 2 logarithm base 10 of m, which is 100. And in this case, it's going to be the logarithm base 10 of 10,000. Because if you square the 100, you get 10,000. And this is a 2. And logarithm base 10 of 100, we know it's 2. So this is going to throw you a 4. And over here, this one, we already have it. It's right here. It's a 4. So 4 is equal to 4. And there you go. So you have your 3 equivalences. Let me circle those equivalences, which are going to be this one right here. And this one right here. And this one right here. 3 equivalences, 1, 2, and 3. And let me do an example how to apply this to measure the intensity of sound. Let me do it in another one here. So let's say you have an intensity of sound is pressure, or it's power. There you go. Power divided by area. And let's say that the intensity has a power of 10 to the minus 3 watts. And the area is 1 meter square. So the formula to measure the sound is this one. And that's for decibels. Decibels are equal to 10 logarithm base 10 of intensity of the sound that you want to measure over an intensity of reference. And your intensity of reference is going to be 10 to the minus 12. 10 to the minus 12 watt over meter square. That's your intensity against the one you're going to measure the sound. So this is your reference intensity all the time. So in our case, this is going to be equal to 10 logarithm base 10 of 10 to the minus 3 watts over meter square divided by our intensity of reference, which is intensity sub naught. It's going to be 10 to the minus 12 watt over meter square. And you're going to cancel your units, of course. So the intensity of your sound is going to be 10 times logarithm base 10 of 10 to the minus 3 times 10 to the 12, because this minus 12 goes upstairs, but it goes positive, the exponent. So the intensity of your sound is going to be 10 logarithm, base 10. And again, you don't have to write the 10 all the time, but I'm letting it here. I'm putting it here for simplicity. It's going to be 10 to the 9 here because minus 3 plus 12. Minus 3 plus 12 is going to throw you a 9. So this is going to be 10. And the logarithm base 10 of 10 to the 9 is 9. So this is going to give you 9 decibels. And the intensity of a sound that has a power over area, which is the intensity of 10 to the minus 12 watts over meter square. If you want to measure it in decibels, it's 90 decibels. And that's an example. We'll do more. Thank you.